Dear student, today I will take the subject Applied Hydraulics Module 2 Uniform Flow in Open Channel. Okay, here open channel. The open channel, there are different types. Okay, is classified. The open channel is classified natural and artificial. Okay, here the open channel is classified as a natural and artificial. The natural, the stream, river, etc. And artificial is the man-made. Okay, is the man-made. Okay, there are different types of the artificial channel. You observed is the rectangular, trapezoidal, triangular, and circular. Okay, there are different types of the man-made open channels. So the open channel is classified natural and artificial, the natural stream, river, etc. And artificial man-made is by the human power. Okay, there are different types of the artificial channels: rectangular, trapezoidal, triangular, and circular. Okay, what do you mean by open channel? Okay, open channel flows are those that are not entirely included within rigid boundaries. A part of the flow is in contact with the atmosphere. Means, just take the example of the trapezoidal channel. Okay, means here there are not entirely included within a rigid boundary. Means water is not completely covered by the rigid boundary. A part of the flow is in contact with atmosphere. Means this part, okay, this part is in contact with the atmosphere. Okay, so flow in open channel is defined as the flow of a liquid with free surface. This is the free surface. Okay, and this surface having a constant pressure. Is called as a atmospheric pressure. Okay, this pressure is the same as a atmospheric pressure. Okay, see, just take the longitudinal section of the open channel. Okay, is the slope I, because the open channel, already studied, the open channel flows under the atmosphere pressure. Means due to the gravity force, the water flows under the gravity force. Means here no any pressure, no any external pressure. Okay, is only flows due to the gravity force. So we need some slope with a datum line. Okay, this is the datum line, take it as a datum line. Okay, this is the bed of the channel. Okay, this is the bed of the channel. So here the water flows with the free surface. This is the free surface. Okay, this is the longitudinal section. Okay, here it is the longitudinal section. Okay, just take it as a, this is the cross section. Okay, water flows depth, you can take it as y or d. Okay, whatever, or d. Okay, you can take it as y or d. Okay, see here the water flows with a free surface in contact with the atmosphere and having a constant pressure. So constant pressure is acting at the surface, is called as a, is the atmospheric pressure. Okay, atmospheric pressure. We know here dou p by dou x means pressure gradient is equal to 0, because here the pressure is not going to change. Okay, pressure is a constant, p is equal to constant and is equal to atmospheric pressure. Okay, is equal to atmospheric pressure. Tau naught, shear stress, the shear stress just below the surface. Tau naught is the shear stress just below the surface, water surface, is equal to 0. And normal stress, sigma n, normal stress is equal to the constant pressure, P, is equal to atmospheric pressure, P atmospheric. Okay, here in a free surface the constant pressure is acting. Okay, is a atmospheric pressure. So you got the clear pictures about the open channel flow. The open channel flow are not entirely included within a rigid boundaries. Means not entirely included within a rigid boundaries, and a part of the flow is in contact with atmosphere, is called as a open channel flow. Okay, there are different types of the channel, you know, the triangular, rectangular, circular. See, if it is circular, okay, just take it as a circular, is completely closed, but it is not entirely covered with a rigid boundary. See here, the water may be just below the top surface. Okay, generally we using the sewer for the drainage purpose, and water supply we are going to use. So here the water level is somewhat above the diameter at the middle. Okay, so here this is the air, okay, is filled by air. So here also the constant pressure P is acting is a atmosphere pressure. Okay, here also it is the open channel flow. Okay, so here already you know the open channel flow, and next we go for the classifications of the open channel flow. Okay, see, this is the diagram of the open channel flow. See here, there's the longitudinal sections. Okay, the dou p by dou x, pressure gradient is equal to 0, and constant pressure is acting at the free surface is the atmosphere pressure, and sigma n is equal to p, and is the normal stress. Okay, this open channel flow is only applicable in a liquid. Okay, but you know the fluid means it is the liquid and gas. Okay, so here gas is not possible, because you know gas is expand. Okay, gas expand and it takes the shape of the boundary. Okay, so here it is not possible, so only it is generally we are going to use the channel for the supply of the water. Okay, okay, next, classification of flow in a channel. The open channel flow can be classified in a different ways. Okay, now depends upon the variation of the flow parameters with respect to time. Means there are different flow parameters. The depth, there are different flow parameters. Depth of the channel, depth of the flow, depth of the flow, and velocity of flow, and discharge, q, discharge or rate of flow, discharge of flow, and I, the slope of the bed, and area, cross-sectional area of the flow, cross-sectional area of the flow, or wet area, or wet area. So classification of the flow in channels. Okay, the open channel flow can be classified in different ways. The first one is the variation of flow parameters with respect to time. Means variation of the flow parameters, these are the flow parameters with respect to time. And variation of the flow parameters, this variation of the flow parameters with respect to space, and based on the Reynolds number and based on the Froude number. Okay, the first one is the steady and unsteady flow. Okay, the first we are going to study about the steady and unsteady flow. Okay, what do you mean by steady flow? Here the flow parameters is such as depth of the flow, velocity of flow, and rate of the flow at any point in open channel flow do not change with respect to time. Okay, just take the longitudinal sections. Okay, take it as a section 1 1. Okay, see here, the flow parameters such as velocity or depth yt1 means the depth of the flow at time t1 is equal to depth of the flow at time t2. Means here the flow parameters such as a depth of flow, velocity of flow, and rate of the flow at any point is not going to change with respect to time. Here the depth, velocity, and discharge is not going to change with respect to the time, is called as a steady flow. Means it should satisfy the conditions dy by dt or dou y by dou t is equal to 0, dy by dv by dt is equal to 0, and dq by dt is equal to 0. Means here the depth of the flow and velocity of flow and discharge of the flow is not going to change with respect to time. Means y is constant, here y is a constant, and velocity is constant, and q is also constant. Means here the velocity, depth, and rate of flow is not going to change with respect to time, is called as a uniform flow. Okay, for uniform flow it should satisfy all these three conditions. Okay, in uniform flow it should satisfy these all conditions: the depth, velocity, and discharge should maintain constant. Okay, next, unsteady flow. Okay, next go for the unsteady flow. See here, in unsteady flow means the flow parameters such as I already studied is the depth, velocity and discharge is going to change with respect to time. Means dy by dt is not equal to 0, dv by dt is not equal to 0 and dq by dt is not equal to 0. Okay, here the y, v and q means depth, velocity and discharge is not constant. Here in unsteady flow, the velocity, depth and discharge is going to change with respect to time. Means here, see, just take it as a, see here is the longitudinal sections. Okay, we are going to measure the velocity and depth at section 1 with respect to time. Okay, see here yt1 not is equal to yt2, means the depth of the flow at the time t1 is not is equal to at the time t2, means it is going to change with respect to time. Vt1 is not is equal to Vt2, Qt1 is not is equal to Qt2. Means here the simple concept is, here in unsteady flow the flow parameters such as a depth of flow, velocity of flow and discharge of flow is going to change with respect to time. So here dy by dt not equal to 0, dv by dt not equal to 0, dq by dt not equal to 0, and here the y, v and q is not constant. Okay, is not constant, is going to vary. Okay, so you got the clear pictures about the steady flow and unsteady flow. Simply you can tell steady flow is defined as the flow parameters such as a depth of flow, velocity of flow and discharge rate of flow is not going to change with time. With respect to time is called as a steady flow, and it should satisfy the conditions dq dy by dt is equal to 0, dv by dt is equal to 0, dq by dt is equal to 0. It should satisfy all these three conditions. If any conditions fails, then this is not the steady flow, it will be the unsteady flow. It should satisfy all these three conditions. If it is not satisfied any one conditions, then it will be the unsteady flow. Okay, so here y, depth of the flow and velocity of flow and discharge of flow is a constant. Okay, in unsteady flow all these three parameters is going to vary. Okay, next we go for the uniform and non-uniform flow. The first one is uniform flow. Okay, what do you mean by uniform flow? Okay, see here already you know the flow parameters, the velocity, depth, discharge and slope of the bed. Okay, slope of the bed I and cross-sectional area or wet area. Okay, here in the flow parameters such as the depth of the flow, velocity of flow and slope of the channel and cross-sectional of the flow do not change with respect to space. Means see, it is in 3 dimension. Okay, x, y, z is collectively called as a space. Collectively called as a space. Okay, here the length of the channel is in x direction. You are going to take it as an x directions. Okay, but collectively we can call it as x, y, z is called as a space. Yes, coordinate. Okay, x, y, z. Okay, so here in the longitudinal sections, just take it as a longitudinal section. Let's just take it as a section 1 1 and take it as a section 2 2.